go on. Question number 2. First of all, to get the answer in the textbook, you need to, there's a little typo, so that C in the second bracket shouldn't be there. If that C is not there, it does work out. You get x squared b to the half c to the minus 2 as the answer. Now, if we put the numbers in, so we know that a equals 3, so it's 3 squared times b to the half, so it's 4 to the power half, times c to the minus 2. So that's c to the minus, 2 to the minus 2. Minus is 1 over, so it's 1 over 2 squared is another way of writing it. And if you write it like that, you actually don't need a calculator to work it out. 3 squared is 9 times 4, the square root of 4, because power half means the square root, is 2, divided by 2 squared is 4. So that actually turns out to be a half of 9, and 9, which is 4 1/2. The question is, though, why plus minus? And the reason is because when I square root a number, that's this bit here, then the answer can be positive or negative. Let's just think about that for a minute. The square root of 4 parts, which is this bit. The square root of 4 is or minus 2. Because if I square minus 2, Sabika, I get 4 as well. Okay? So whenever I square root a number, the answer could be positive or negative. And so that means when I come to here, this should be multiplied by plus or minus 2, which then gives us plus or minus in the answer. Okay? More on that when we come to look at quadratic equations and functions. We always get 2 solutions, and that's why. In an engineering situation, often we're only interested in the positive answer, so we ignore the negative, but that doesn't mean to say it doesn't exist. Okay? So that's the first note I wanted to make. The second note was to start you off on this one. Well, if we look at it, we've got some division, so we've got negative roots to worry about, and negative powers rather to worry about, and also the roots. And as the roots are underneath, they could be negative too. So if I would do this in these stages, the first paragraph is already in power form, so leave that as it is. And the second paragraph, AB to the power third, that's this bit here. If you think of 3 times 2 squared, think of some numbers for a second, then 3 times 2 squared, 3 times 2 is 6, 6 squared is 36. I could actually square each of the numbers inside and I still get answer 36. So I can write this as a to the power of third multiplied by b to the power of third. So that's the first thing to recognize about this one. So the second bracket can be written like that. Over, now let's think of these in power form. Remember, square root of a cubed could be written as a to the 3 over 2 multiplied by, that's just the square root of b, so that's b to the half times c. The square root doesn't extend beyond the b. So this equals a cubed, which is the first bracket, b to the half, c to the minus a half, times, in the second bracket, a to the third, b to the third. Now, I can bring these up and call them negative. So this will be a to the minus 3 over 2, b to the minus a half, and c to the minus 1. So I use the laws of indices to write everything on the top line and call it a negative power for the final bit. And now I can add together all the a's, the b's, and the c's. I can add a 3 plus a third minus 3 over 2. So there's a bit of fraction work to go on. For the b's, it's a half plus a third minus a half, and so on. So to do these sorts of questions, the first thing to do is to rewrite each bit in this power form so that you can then combine them together using the first laws of indices. Okay, so I won't finish that off, I'll leave you to finish it. We'll pause there, it's now 10 past. Well, just gone nearly quarter past, so let's say 20 past. Okay, back here.